Okay, so this will be the second video of or part two of writing a driver or writing a driver to communicate with these two joysticks using an ADC device, external device, and communicating through an NRF. So on the last video, we wrote a driver or class to communicate with the NRF, and then sent data using the NRF back to this one here, and then send it back to the phone using an HM11 Bluetooth device and displaying it on the phone right there. Right, so if I run it, you'll see that data is being sent. Let me stop it. This is the same data as before. So in this video, we are going to write one to communicate with this ADC device, external device. This is the ADS1115 from Texas Instruments. And we're going to get input from these two joysticks. The joysticks have two outputs, one for X and one for Y, so just shows different values depending if you're moving it left to right or forward and back. So let me show you what we have. This is the code from the last video. Nothing has changed other than a correction of a typo there. And on the right, we have the ADC data sheet. It has 4 registers. The first one is for converting data or for getting the converted data. The second one is the configuration, and we can read and write to that configuration. The last two, we don't care. We don't have any use for it in this video. So to communicate with this device, it requires us writing a byte to the device and using the first 2 bits to tell it what the intention is, either reading or writing, right? So you tell it 0 if you're going to be reading the converted value, or you write a 1 if you are going to write or read the configuration. And the way this is connected on my setup, I have the ADC device connected to these two pins, GP14 and 15, and it's on port 1 of the I2C. So let's start writing the code for it. So first thing we're going to do is get all this code and put it on a separate file. I'm going to copy, create a new file, delete this part. We only want the class at the top, and we'll save it inside the pico. We'll create a directory. The directory name has to be lib for library. And now we can include our files that we can include in our main code. So we'll go inside and give it a name. This will be nrf lib lowercase py. So now that we have that, we can come to the main file and delete that part, include it, and if we run the code, let me show my phone. If we run the code, it should work just the same, right? Nothing has changed. Now we have a library that we can include whenever we need to. And let me hide my phone. We don't need it anymore. So let's start writing the one for I2C. So this is the reference I'm going to use for I2C for MicroPython. It has all the examples I need and the constructor of what is required right there. Okay. So let's create a new file right from the start. We'll save it. That's not what I wanted. Let's save it. I'm going to save it in the pico. We're going to save it inside that folder. Name it ADS lib.py. So now we have our file here, and we'll start by importing utime, and then from machine we'll get pin, and the same for I2C. Create a class. The class will be, let's call it double joystick. Initialize. And now we need an ID. So we need an ID, SCL, SDA, and let's include frequency as well, even though it's not needed because it's already set to 400. But let's just do that, right? So we'll include port, and we said that our pico is connected to port 1. So we're just gonna default it to 1. And then we have a frequency, and we'll default that to 400K. SCL will be 15, GP 15, and SDA 14. Now to initialize I2C, we simply say I2C, and we'll add the port frequency equals frequency SCL and SCL SDA SDA. We have it. So the next thing we need to do is we need to find the address. I2C is all about addresses on the devices. The address is somewhere up there, but if you don't want to search for it, you can simply scan the devices that are connected and then just print the results, and that will give you the address of any device connected to the pico. So we'll say print devices, cell, and so devices equals cell dev scan, and for device and devices, we'll print the device and the device. There we go. So now we should be able to test that. So let me save it, go to main, including here from ADS live import double joystick. Okay, let's test it here. Dev equals double joystick, dev and devices, and we'll do a loop. Run it. First error says self. So that's a typo on line 9 of the ADS right here. Self. Should be able to run it now. Oh, gotta save it first. There we go. And we see that we have our address. So now that we have an address, we should be able to go read data. So let's go read the configuration, which is bit register number 1. And this is the same as before. Devices, for the most part, it's all about reading and writing to registers. So the function is similar. Read register, self, and the register we want to read. And we'll just say, I guess, result equals self dev read from. Take that back. We have to write first what we're going to read. So let's do self dev write to, and then a self address, which means that we have to set that as well. Self dev address, we'll set it to 0. And then when we call it, we'll set it here after it's been initialized. So address 72. That's right there. All right, so address, and then we specify the register. So byte array, and it will be the register. And because we want to make sure that only 2 bytes are written to that register, we are going to mask it. So register will be 1, 2, 3, 4. 1, 2, and 1, 2. So only the last 2 bits, or the first 2 bits, are the important ones here. Okay, so now we can read it. So we'll say result equals self def read from self address, and we specify how many bytes. We're always going to be reading or writing 2 bytes because that's how the registers are set. You can't write 1, it has to be 2, and you cannot read 1, it has to be 2. You could read 1, but the data would be useless. And then we return, right? But we want to return it in an actual value. So we'll say result. We're going to shift this 8 bits, and then we'll add the other first 8 bits. So that's 1. That's it. So now that we have this, stop this. Okay, so now that we have that, we should be able to test it, right? We should be able to read the configuration. So we'll put a timer here, sleep, and then we'll get the configuration, the read register, and that would be number 1. And we can print it. So we'll print A and A as well. And we should get every 1 second, we should get not the address, but we're going to get the configuration. 19, typo or invalid 6 syntax. Okay, it has to be def. So there it is. So that is our configuration, and that's the incorrect configuration. That's when I was testing to see the default configuration. I disconnected the device, plugged it back in. So that's the default configuration. All right, so this is what you're seeing. You can see the last bit is 1, which is this OS, and the default is 1. So you can see there's a 1. And then the rest are zeros all the way till you get to here. Now you have a 1. So that's 1 and 0 and a bunch of zeros. In any case, so now that we can read, let's add something to write to this register. However, because we are going to use, there's only 1 register to write and read from, as far as configuration goes, we're going to use the same one to do the same thing over and over. So we're going to read it and we're going to write it every time we either need to initialize a conversion, or we need to change the configuration itself, right? So let's take all the defaults of the configuration and then make changes as we go. So the first function, or the function we need for this, we'll just call it config. And this one will take, we're only going to pass the bits that are relevant. So it will be OS, and we'll default it to 1, the same way as here. The next one will be the multiplexer, or the channel that we're going to be converting. We're going to be using the last 4. So from this one all the way down. The first 4 is a mix of inputs, and we don't want that because that's incorrect data for what we're trying to use it. So we're only concerned with those. And we're going to assume that this is channel 0, 1, 2, and 3. So we're going to say channel equals 0. And then we'll move the bit to the left, so it's actually a 4. The next one is gain, this one here. And that one will be set to, let's set it to 1. So we're not going to take this default. We're actually going to go up to 1. We'll see. We might change it. Yeah, let's go back to 2 instead. Be 1 0. Okay, so we'll keep the default we have here. And next will be the mode. So the mode will be set to 1 because we want single conversion. We want to be able to control when it's going to convert, so we have a chance to change the channel it's going to be reading from. And when we read the data, we want to make sure that it's still in that channel and we're not reading erroneous data because it might be coming from a different channel. Okay, so it's going to be always 1, at least in this case, so we're defaulting it to 1. We want the rate, the rate will be defaulted to same thing that it has there, which is 100. And what else do we need? That's it. So and it should be rate, not date. Okay. Now we can do the config. So the configuration will be OS. We'll push it 15 bits to the left. The next one is channel. And because we said we were gonna start at 0, but assume that it's a 4 right here. 100 is a 4. So we're just gonna add 4 to it, and then we'll move it whatever number of bits it says here, 12. Next one is gain. And for gain, we're moving it 9 bits. What else? Mode. This one is 8 bits. And rate, 5 bits. And we're not going to do anything with that, but we are going to make sure that this one remains disabled. So it's a 3 or that. It's a 3. Right? So we'll just leave it at 3. So we have the configuration set. So now that we have the configuration, we can say self dev write to self address, and we specify a byte array. Because this is the configuration, we know it's a 1, right? It will always be a 1, and we'll include the config. This is going to be a problem. Yeah, it will be. Okay, so this one is expecting single bytes, and this is 2 bytes, so we need to split it. So let's do convert it to 2 bytes. So that will be config equals, actually it should be just that. So int config, whenever we decide to have I, and then we're gonna mask it, so it's only 8 bits, and for I in 8 bits and 0 bits. So that should give us 2 bytes. And just to test it, we'll print it. Okay. Device is busy. Stop it. Save it. So we'll test this config here. We'll print it every time it goes by. We'll just say dev config. And there's print on line 30. That is mistyped. There's line 30 right here. Print. Save it. Go back to main. Run it. So you can see that it is 2 bytes, 197, 131. So we're good with the configuration. So that means that we should be able to, because we have the configuration running on every pass, we should be able to read data from from one of the joysticks. So instead of reading 1, we'll read 0, and that should give us actual values. And let's remove the print from this one here. And run it again. So this is actual values. It looks like it's an actual value. So if I move the joystick, is it changing? Yeah, you can see that it's changing. Right? Let's change the gain. The number is a little high for my liking. So we'll go back to this one and change the gain to 1. All right, that's better. So 15,000 when the joystick is idle. if I move to the left, you can see it goes 26,000. If I move to the right, now it goes below 4,000, below 5,000. Okay, so with those two, we should be able to write one more function and we'll be done. So what we want to do is we want a function that is going to read an input and then move to the next input, read it, move to the next input, read it, move to the next input, and then come back to the first input or to the first channel. So all we have to do is just say go read data, and it'll know which channel to read and which one to set for the next one. So let's do read joystick inputs. Okay. We're going to need a way to store this data and a way to keep track of the channel as well. So self joystick inputs is 4 channels, so that's 4. Current channel, this will be set to 0. So now we can come here and oh, the other thing we need to do is that this bit right here. So it has dual purpose. So if we are writing to it, we write a 1 to initiate a conversion. When we are reading from it, a 1 indicates that we have data available, and if it's 0, it's busy reading or converting data. So when you write a 1, it immediately flips it to 0 and it goes to work. So we need to check, make sure that data is available. So we're going to say if not self read register, and this is the configuration. So it's bit number 1, and it should be 15. So if it's not a 1, that's what this means. Then we're going to return. It means that the data we have is not usable. So if we go past this, then we can say, okay, well, give me the result of whatever we have. So read register 0. Right. So once we have our data, we can use our own function to get the conversion value of whatever we have, and we can say self joystick inputs. We can say self current joystick or current channel equals result, and this needs an equal sign. Right. So next, what we want to do is we want to increment the channel. So self current channel equals 1. And we want to make sure that it doesn't go over 4. So we'll say if self current channel is more or equals to 4, then we say self current channel equals 0. So it'll wrap around 4. And the last thing we want to do is we want to start the new conversion. So we'll say self config channel equals self current channel. Right, so that will set the next conversion by overriding the channel itself. So this should give us data for what we want. So let me stop this, save it, go back to this one, and instead of doing this, we actually don't need any of this anymore. That's the wrong one. This one. So we don't need any of that except for the config. Actually, we don't need config either. We just need it the first time, like that. Just get started a conversion. Right, and we'll make it so it reads really, really fast. We'll put a counter here just so we can display data only when we need it and not on every cycle. So we'll say counter equals count or 1. If counter is more than, let's say, 100, then counter equals 0. Also, we want to print whatever is in the joystick inputs. Okay, and the last thing we do right here, we say that read joystick inputs. I believe that's it. Let's see how many errors we have. Run it. So there's a typo there on line 36. 36 right here. So there's another one, still the same, line 39. 39. Back to main. Run it. Okay, so there we have data there, right? Or it's moving, it's not printing anything. We have to figure out why. But let's see. Let's run it faster. Let's see if we get some data now. All right, there's nothing there. Let's see, why isn't it something? Counter +1, counter more than 10, print. So we'll just say print here. Comment this out. Comment this out and see if that one's causing it to crash. What am I doing incorrectly here? All right, that one's executing. That one's executing as well. It is looping. So counter +1. If counter is more than that, then counter equals 0, and then we print something, and that is it. What am I doing incorrectly here? And I just print. Is it because it doesn't have the equal sign? No. I'm not seeing something here. Stump. Counter. Where is this being set? Is it the same? Yep. Counter equals counter +1. If counter equals that, then print utom. Let me remove this part. Remove that part. Jesus, I don't see it. Print counter. Oh, it's always 1. Oh, it have the plus sign in front of it. Okay. So we'll remove this part, and then we can say dev here, dev or print dev joystick inputs, and then read joystick inputs. All right, so stop this. Where's that print? This print right here. So we'll print the data every 10, I guess. So there's the data we have, right? So there's my the column on the left is for the joystick on the left. So I'm doing left, right, forward, and if I do the other one, same thing. Data is a little difficult to read, so let's make a change here and make it so what I want is if it's left, this is going to be -1. If it's idle, it'll be 0, and if it's right, it'll be 1. So let's change this, and we'll say -1 if channel is more than, let's see, if it goes more than 26, if it goes more than 20, if it goes more than 20,000 and less than 8,000. So if it goes more than 20,000, else 1 if result is less than 8,000. Okay, else 0. Let's see what we get. Okay, run it. Line 41, there's an error on line 41 already. -1 if result is more than 8,000, I mean 20,000. And there's our zeros. Joysticks are idle, so let me do left, forward, back, right. So left, right, and then on the right side, left and right, forward, and back. So that's what we have. So now we can send that same data to the other unit, and let's see. Let's send the data so we can display it on the phone, and then we'll see the whole thing going. So we'll move this. We don't need this anymore. We'll move it here. And instead of printing data, what we're going to do is right here, we'll just say message equals, let's call it joystick. And it will be, let's format it as well. Let's not format it right now. So we'll add whatever data we need to add here. So we want a delimiter, join, and we're going to join str. Let's say I, or I in the joystick inputs. Yeah. And then we can say nrf send message. And the message is message. So let's see what we get. Let's show the phone and compile this and see if it's going to work. Run it. And it's popping up on the phone, as you can see. So if I move let me switch my view. So there's on the phone. So if I move this joystick to the left, you can see it's -1. To the right, it's +1. Forward, second column is 1. Back, second column is -1. Same with this. I am using 22. There you go. To the right, forward, and back. So that's pretty much it. This is the demo. It was a long video, 34 minutes, because I couldn't see the error that I created. So now what where you take this is, I guess you can connect a couple of DC motors on this side, and then you can control a remote control car, or a quadcopter. The joysticks are not really sensitive, so that's why I'm displaying either a 0 or a number. They're not linear enough to give you enough accuracy when you're reading that data. So in any case, this is how you write a driver. You can see that they are on separate files, and they have to be in a folder called lib. And once you have that, then you can have access to them. So here's how I'm adding both of them, and then instantiating each one of those. And then you can just go ahead and use them. So it makes your code a lot cleaner when you use drivers. And obviously, it's important that you understand how drivers work, because if you just copy someone else's and you pass the wrong data, it crashes and you have no idea why. So that's all I have. I will include the code, the link to the code itself, and we'll see what else we can come up with. So enjoy.